Hello, college prep math students. It's Mr. Bethia here. I hope all of you and your families are doing well. Today, we're going to get some more practice on systems of equations word problems. And just a couple of reminders before we get started. Make sure you're submitting all your assignments on Google Classroom. The next assignment has been posted and it is due on Friday, April 17th. Make sure you turn it in by 3 p.m. on Friday, because that assignment counts towards your attendance, and I need to see that submitted before 3 p.m. on Friday. Also remember that I have office hours on Mondays, Wednesdays, and Fridays from 10 a.m. to noon, as well as Tuesdays and Thursdays from 2 p.m. to 4 p.m. So please come to office hours if you have questions about any of the assignments. Okay, so let's go ahead and dive right in. We've seen these criteria for success before, so let's look at example problem 1 and make sure we're meeting all those criteria. So example problem 1 says a ground meat mixture is formed by combining meat that costs $2.20 per pound with meat that costs $4.20 per pound. How many pounds of each were used to make a 50-pound mixture that costs $3 per pound? So let's remember our first step here. We need to define the variables. And a lot of times those variables are going to be in that last sentence. So here it's asking how many pounds of each. So that's really giving us our variables. We have two types of meat, the $2.20 meat and the $4.20 meat. So let's write that out. So I'm going to use E, let's use C for the cheaper meat. So let's C equal, let's say, number of pounds of $2.20 per pound meat. And then our other variable, let's say, let E equal number of pounds of $4.20 per pound meat. So that's our first criteria for success. Next part is writing our equations. Now, in order to do this, what I would do here is calculate the total cost of the final mixture, because we have 50 pounds and it costs $3 per pound, so we could very easily calculate the total cost there. So let's calculate the total cost of the final mixture. So to do that, we know that we have 50 pounds and it costs $3 per pound. So to get the total cost, we would just multiply that weight by the cost per pound. So we have 50 pounds times $3 per pound. And that is going to give us 50 times 3 is $150. Okay, so I think we're ready to write our first equation. So we know it's the final mix is created by combining this meat that costs $2.20 per pound with $4.20 per pound meat. So the cost of the cheaper meat, the total cost of the cheaper meat in the mix, can be found by multiplying its cost per pound, 2.2, times the number of pounds. So for example, if we had 2 pounds of the cheaper meat, it would be 2.2 times 2, or $4.40. So that's why we're multiplying here. Same thing for the expensive meat. So we need to add the cost of the cheaper meat and the cost of the more expensive meat to find the total cost. So for the more expensive meat, we're going to take the cost per pound, $4.20, and multiply it by the number of pounds, which we defined as E. And that is going to give us the total cost, which we found to be $150. So that's our first equation. For our second equation, we could just use the fact that the total weight of the final mix is 50 pounds. So if we add the weight of the cheaper meat plus the weight of the more expensive meat, we're going to get 50 pounds. Okay. So that is our second criteria for success, writing the system of two equations. Now we need to solve the system and show all our work. You could use elimination or substitution here. If we look at that second equation, it's going to be pretty easy to solve that for C or E, so I'm just going to use substitution here. What I'm going to do here is subtract E from both sides and solve for C. Okay, so we get C is equal to 50 minus E. And then I'm going to substitute that expression into the first equation for C. So we have 2.2 times 50 minus E plus 4.2 E is equal to 150. And here we just need to solve this equation for E. So I'm going to distribute this 2.2. So 2.2 times 50, that is actually 110. And then 2.2 times E, so 2.2 E. Notice we have a minus sign there, plus 4.2 E is equal to 150. And then here we could subtract 110 from both sides. And negative 2.2e plus 4.2e, well, let's think. 4.2 times 2.2 is just 2, so this is actually just 2e. And 150 minus 110 is 40. So let's bring that up here. So we have 2e equals 40. 2e equals 40. And here we could divide both sides by 2 to get E on its own, and we get E is equal to 20 pounds. So that's the weight of the more expensive meat. And then we could use this equation right here to solve for C. So we have C is equal to 50 minus 20, and 50 minus 20 is just 30. So we have 30 pounds of the cheaper meat and 20 pounds of the more expensive meat. So the next step here is to check our answers. So we just want to substitute these answers into the original equations. Of course, if we look at this equation, that's just telling us that the amounts of meat should add up to 50 pounds. So of course, 20 plus 30 is 50 pounds. So we're good there. And let's just check this other equation. So we would have 2.2 times C, so 30, plus 4.2 times E, which is 20. So 2.2 times 30, well, let's see, 2.2 times 3 is 6.6, times 10 is 66, so that's 66. And then 4.2 times 2 is 8.4, times 10 is 84. Okay, 66 plus 84, sure enough, that is $150 rather. So that is correct. We got the right solutions. Now we just need to write our final answer in context. That's the fifth criteria for success. So let's do that. So we're talking about the pounds of meat for each type of meat. So we have, let's say, 30 pounds of the $2.20 per pound meat and 20 pounds of the $4.20 per pound meat were used. And we're done with example problem 1. Okay, so let's go on to example problem 2. Okay, so example problem 2 says a gardener is planting 2 types of trees. Type A is 6 feet tall and grows at a rate of 17 inches per year. Type B is 2 feet tall and grows at a rate of 25 inches per year. Algebraically determine exactly how many years it will take for these trees to be the same height and how tall each tree will be at this point. Okay, so let's take a look at this. First of all, what I see here is that I have units in feet and in inches, right? Feet and inches. So it's going to be helpful here to work with the same units for everything. So what I'm going to do first here is convert these feet measurements to inches. So let's do that. So 6 feet, that's the initial height of the type A tree. So 6 feet. And 6 feet, to convert that to inches, we would just multiply it by 12 because each feet is equal to 12 inches, right? 12 inches per foot. So 6 feet times 12 inches per foot, that gives me 72 inches. And then I'm also going to convert the type B height, which is 2 feet. So 2 feet times 12 inches per foot is 24 inches. So 2 feet is equivalent to 24 inches. Okay, so now I'm ready to define my variables. So here, it's a little bit tricky because I actually have 3 variables. I have the height of the type A tree, the height of the type B tree, and then the time or the number of years. So let's define all of that, but I'll tell you, we're still going to end up with a system of two equations, and I'll show you why that is. So let's define our variables. So let's say let HA equal the height of the type A tree, which is in feet. I'm sorry, we're doing this problem in inches. So in inches, and let HB equal the height of the type B tree, which is also in inches. And then we have the time. So let T equal the number of years, right? Because it's telling us that type A grows at 17 inches per year, type B grows at 25 inches per year. So that's how I know my unit of time here is years. So let's see if we can write some equations. So let's start with the height of tree A. Well, it says it starts out at 6 feet tall, which we found to be 72 inches, and it grows at a rate of 17 inches per year. So to find the additional growth for a certain number of years, what we could do is take that rate and multiply by the time. Because if it grows for 1 year, it would grow 17 inches. If it grows for 2 years, it would grow 17 times 2, which is 34 inches. If it grows for 3 years, it would grow 17 times 3, or 51 inches. So to calculate the total growth, we take that rate and multiply by the time. So 17 inches per year times the time it grows, which is t. And then, let me just rewrite that, make sure it's a clear 17. There we go. And then we have the height of tree B. So this is going to be similar. Type B starts at a height of 24 inches. And this one grows at a rate of 25 inches per year. So we would take that growth per year and multiply by the number of years to find the total growth. And those are 2 equations. Now, notice here we have 3 variables, 2 equations, but it does give us one crucial piece of information in the problem. It says we're looking for when the trees are the same height. So in other words, when is HA equal to HB? So that's the question we're trying to answer. And what that means is we could either make this one variable, we could just change the HA and HB to H, and then we have 2 variables, 2 equations, or we can kind of, plug in one for the other. And that's what I'm going to do. Since we know that HA is equal to HB when the trees are the same height, what I'm going to do is plug in this expression for HB. I'm going to plug that in for HA in that first equation. So we have 24 plus 25t is equal to 72 plus 17t. And now I just have an equation. I just need to solve it for t. So I can subtract 17t from both sides. Remember, we're trying to get t on its own. I can also subtract 24 from both sides. So the 17t cancels over here. The 24 cancels over there. 25t minus 17t is just 8t. And 72 minus 24 is just 48. And then we can divide both sides by 8 to get t on its own. T is equal to 48 divided by 8, which is 6. And remember, our units here are years. Now, the problem is also asking us how tall each tree will be at this point when they're the same height. So what we could do is substitute this number of years into either of these equations. And what I'm actually going to do here is to substitute into both equations. And that's going to allow us to check our answer at the same time. Because if this time is correct, what I should find is that HA and HB are equal to each other when t is equal to 6 years. So let's check that. So HA is 72 plus 17, and t is equal to 6. So we have 72, let's see, 17 times 6, that's actually going to be 102. And 72 plus 102, that's actually 174. Remember, our units here are inches. So that's the height of tree A. Now let's just check the height of tree B. So for tree B, we have 24 plus 25 times t, which is 6. So 24 plus 25 times 6, that's actually 150. And then 24 plus 150 is 174 inches. And sure enough, we have the same height for both trees, which is exactly what we wanted. So we have our answer here. The time is 6 years, and the height of each tree at that point is 174 inches. So let's write our sentence. It will take 6 years for the trees to reach the same height and each tree will be 174 inches tall at this point. So that's our answer for example problem 2, and we're done. So a couple of reminders here. Remember, you have a new assignment due on Friday by 3 p.m., Friday, April 17th. There are 6 problems on Google Classroom. Make sure you submit those. And remember to come to office hours if you have questions about any of the assignments. And I'll see you next week.